All right, we need to get looking at things here. I think things going. This is an A day. Well, I'm gonna have to color that up, make that darker. That's pretty light. This is an A day Friday, so that means we only have class again on Thursday, and again it's optional. I don't think anyone in here currently has less than a 70%. Have to double check, but yeah, if your grade's above 70%, Thursday is optional for you on B day. A day is for the A day classes this week on Friday. So anyone in the A day classes you have that you're below 70, Friday is going to be your class week. So all right, I'm going to get up on the screen. We need to go through our lessons today, so we're not sitting around doing nothing all day. Kind of get us started back after the Labor Day weekend. Looking at Algebra 3 0B, let's go to our grade screen. You see, I made a 90% in the last one. I may want to go back and redo that. Remember, you get like 3 attempts. You get 3 attempts each time. So, like on this, if I want to go back here, I can click on revisiting functions, and I can look at the questions. It has the details right there, but I can look at the questions right here to see what I missed. So I can scroll down and say, number 7. So I need to go back and look at that again and see, did I just make a careless mistake? I probably did, but probably made a careless mistake. But I need to go back, and 8, 9, and 10 are all right. I only missed number 7, so I can go back and look at that and decide if I want to redo that or not. But this week, let's see what's due. Oh, we have 3 things, but one's just a quiz. That's not a lesson that we have to cover. So we have a quiz over these first 2 lessons. And then today we're going to talk about writing the equation of a line. Like I said, this is really a review, right? Because you know how to do y equals mx plus b, but we're going to talk about more than one way to do that, and comparing functions. And then we're going to be pretty much done with this unit. This review unit we do pretty quick, so just a couple of weeks. Next week we'll have the review test. I need to see. We may have the test next week. Maybe I'll push it back another week. Let's see. I'll find out. But let's go back to our activity screen and let's go ahead and take a look at that quiz real quick, just to see what it consists of. This first one should just be the instructions. Yeah, so it's just complete the quiz. Before you work on the module quiz, just study everything in the previous lessons, review the practice activities, make sure you've completed all the assignments. And, certainly contact me if you got any questions about the material. I'm happy to go over it with you before you do the quiz. But that's it for the instructions. And let's look at the quiz. Again, you have 3 attempts. So if you don't do well the first time, go back and look at those questions, see what you missed. If you need some help from me, let's see, which of the following represents a function? Which one of these is a function? Consider this function f of x equals. Find the value of fx when x equals 3. Now, your questions may be different because there's a bank of questions. It doesn't just give you the same questions. So people have different questions in there. Which is the inverse of this? Which composition produces the greatest output? Oh, so if you do f of x and g of x, write those equations, what f of g of x and g of f of x is, and see which one produces the greatest output. Like when you put x in there, pick an x, put an x equals 2. Which one gives you a bigger number? F of g of x or g of f of x? Or do they produce exactly the same? Or does it not work? When you put it together, you can't get a number out of it. And this question has 2 parts. Here's an equation where you're supposed to solve for the x, showing each step. Make sure you show each step. And then part B is where this dude named Jeff solved this one. And did he do it correctly? Is it correct? Yes or no? If not, what did he do wrong? If he didn't do it correctly, what did he do wrong? So just 5-question quiz. And that's worth a few more points than our assignments, because that's actually a quiz to see how you're doing on the first couple of lessons. So that's this week, the quiz. Now let's look at our first lesson for the week, writing the equation of a line. Again, review. The navigator of an airplane has responsibility of setting the onboard computer at the plane's correct trajectory. Trajectory, that's a path of a moving object following through some kind of space, which this would be just the air. Equations representing the descent between critical points worked out beforehand and activated at the precise moment upon the airplane's approach. So I guess we'll watch their little video here. This is 52 seconds. Not bad.
This airplane is 28 miles from the airport and ready to begin its descent. It is still 4 miles above the ground. Precise equations are activated that allow it to approach the airport safely. Moving along a linear path, the plane descends to an altitude of 3 miles above the ground and 16 miles from the airport. Taking on a new trajectory, the airplane continues its descent until it is just a mile above the ground and 8 miles from the airport. Following its final trajectory determined by a precise equation, the plane comes in for a landing.
All right, so if we take a look towards the end of that, we see we have three different lines there. See, this only goes down 1 mile over a period of 12 miles horizontally. So over a period of 12 miles, it came down 1 mile. And then in just 8 miles, it came down 2 miles. And then that last 1 mile, it takes it 8 miles for it to go there. So it's half of the slope of this one, right? Because this went down 2 miles in a period of 8 miles, and this one goes down 1 mile, 8 miles till it lands. So three different linear equations there. So a pilot planning the airplane's trajectory is similar to writing the equation of a line. Just like the pilot must be precise with his planning on his trajectory, you got to be careful and precise in working through your equation. So here's what we're going to learn. What methods are useful to create the equation of a line, and what restrictions might be necessary to the domain and range of linear equations. All right, different forms. This is what we're going to look at, different forms, because you know the y equals mx plus b. That was the first one you learned a long time ago. Like here's y equals 2x plus 1. 1 is the b, that's where it crosses the y-axis. 2 is the slope, because from that point it goes up 2 and over 1. 2 over 1 is reduced to just a slope of 2. So you've learned two ways to write the equation. The standard form, which is ax plus by equals c, and the slope intercept, which is much more useful for graphing. We can't really graph ax plus by equals c, but we can recognize that as the equation of a line. So with the equation of the line with the slope of 2 and a y-intercept of -4, we would substitute 2 in for the m, -4 in for the b, and so our y equals mx plus b equation would be y equals 2x minus 4. Right? That's a nice little review. If you want to hover over these, you can get explanations. Slope-intercept form of a linear equation is given by y equals mx plus b, where m is the slope, b is the y-intercept. This says the standard form is given by the equation ax plus by equals c, where a, b, and c are all integers, and a is positive number, like 2x minus 3y equals 10. We'd have to do a little work to graph that. We'd have to change it to the y equals mx plus b form. All right, this says, think about it. Explain in complete in sentences. If the equation of a line can be directly written in standard form using a pair of points, the slope, or y-intercept, or would you need to do something else? If you had the y-intercept and the slope, could you write it in standard form? That's the ax plus by equals c. We really couldn't. I mean, knowing the y-intercept does not help us write it in standard form, nor does knowing the slope. But we could write one in y equals mx plus b. Here's a little answer for that. If you thought about it, the integers do not represent any part of the line, so you cannot go directly from those pieces of information. Now, we could start with that and eventually get to the standard form by rewriting it, but we wouldn't be able to do it. What if you were given the slope and a point on the line, but not the y-intercept, right? So, okay, here's the slope. Slope is 3, and it's going to go through the point 3, 7. Does that help you write the equation? Well, there is another way. You may remember the point slope form of linear equation. Y minus y1 equals m times parentheses x minus x1. So let's look at an example of that. So we're going to write the equation of a line that passes through this point, 2, 1, and has the slope of 3. So we know that the slope is y2 minus y1 divided by x2 minus x1. That was the equation of the slope learned back in Algebra 1. M equals, that's how we determine what the m is, by taking the 2 y points and 2 x points and subtracting the difference between those 2 points. So if we know 1 point, 2, 1, we can take this equation, m equals, we know the slope is 3, so we can substitute 3 in for the m right there. And we can put in the 2, 1 for 2 points there. y2 minus 1, x2 minus 2, since we know 2 is the x part of that point. So now we can just take away the subscripts, because we don't have a second. We have 1 point we don't know. 3 equals y minus 1 divided by x minus 2. If we multiply by x minus 2 to get rid of the fraction, x minus 2 on both sides, we get y minus 1 equals 3 times x minus 2. And that is the point slope equation for that line. Point slope. It will go through the point 2, 1, and we'll have a slope of 3. So that achieves what we need. We were only given a point. We were only given the slope. And we can write the equation of the line. And we can even graph that. Let me change how I'm presenting this. So we can take it. We're going to graph it just to prove to ourselves that that is the correct line. So I can just copy this. Copy. Let's go to Desmos. If we just paste that equation here, y minus 1 equals 3x minus 2. So what point did it go through? 2, 1. So let's graph the point 2, 1 by just typing that in. There's the point 2, 1. So as we can see, it is on the line. And what is the slope of this line? It goes up 2, 3, up 3, and over 1. That's where the next time it hits the point. So it does have a slope of 3. So this is the equation of the line that has a slope of 3 and goes through the point 2, 1. So we're just shown how to do that with the point slope equation. So it's a nice example of it. Look at the graph. That is actually it. So let's see. Here's another example to give us 2, negative 1, and only has a slope of 2. So again, we can just start with this form of the equation, the y minus the y1 equals the slope times x minus the x1, and just substitute everything in. X1 would be the 2, y1 would be negative 1, and a slope of 2. So 2 is the m. So you got to be careful because we're tempted to just put 2 in first, but that's not the y. That's an xy point. So you got to make sure you're doing the right thing. And you also got to be careful that y minus negative 1 is actually y plus 1, right? Because when you subtract a negative, you're going to have a positive number. So they'll show you all the steps right here to distribute that, because it says write it in standard form. So if we just had this and we were told to write it in standard form, well, this is not standard form. This is point slope form. But we can start y plus 1, 2x minus 2, and convert it to any form we want it to. So here's the steps. First, we'll distribute the 2, get rid of the parentheses. That gives us y plus 1 equals 2x minus 4. Now let's move the x over to y, because remember, in standard form, x and y are on the same side of the equation. So negative 2x plus y plus 1 equals negative 4. We need to move the 1 to the other side. We'll do that right there. Negative 2x plus y equals negative 5. There was one other thing we need to do, because this looks like standard form, but if you remember, a, b, and c are integers, and a is also positive. A has to be a positive number for it to be in standard form. Well, if you look at our a is a negative 2. That's not a positive form. So we just have to multiply the entire equation by negative 1. Now it's 2x minus 5 equals 5. This is the standard equation of the exact same line that this was. Y plus 1 equals, let's prove to ourselves that it is the same line. We'll go get rid of these, graph this one instead. Okay, there it is. What point was it going through? The point 2, negative 1. So there's the point 2, negative 1 right there. So it does go to that point. It has a slope of 2, goes up 1, up 2, and over 1. There's the next time it hits a point. So slope of 2. And we said the same as 2x minus y equals 5. 2x minus y equals 5. Oh, it is. Look, the purple line is the same as the red line. So we converted it to standard form. And we could also write it in y equals mx plus b form, right? Because we know -5 is where it crosses the y-axis, and we know it has a slope of 2, so that's the same as y equals 2x minus 5. See, now the black line is the same as the purple line, which is the same as the red line. So there's 3 different ways to write the same equation. Point slope is the first one, standard form, and then our y-intercept form right there, the slope-intercept form. All right. And yeah, be careful of those double negatives. Remember, 3 minus -1 would be 3 plus 1. Here's another example, if you need one, on writing the equation of a line given a point and a slope. They use the point, the -3, 5, and the slope of -3. So I'll leave that. If you need to go through that, there's another example for you. Let's look at page 3. Okay, now let's look. What if we're just given 2 points? We had the point and the slope. We had the y-intercept and the slope. Now, what if we're just given 2 points? So we're looking at a 4th way now. So imagine you're a flight navigator trying to determine the equation needed to land the airplane at the airport. You're 8 miles away from the airport and you're 1 mile in the air. 16 miles away, you were 3 miles high in the air. So you can use those 2 points to determine the slope of the flight and then find the equation to land the plane in slope-intercept form. So first we'd calculate the slope. So let's look at how you do that. Remember that equation we had for m equals y2 minus y1 over x2 minus x1 equals 3 minus 1, 16 minus 8. So the slope would be 1/4. So here let's work through that on paper just to give us a little actual practice rather than just looking at it on the screen. At 16 miles away, we were 3 miles in the air. Okay, so remember our equation, slope equals y2 minus y1, x2 minus x1. We take the 2 y's and subtract them, take the 2 x's and subtract them, and it exists as a fraction, basically. Now, we can choose either one we want to be as x1, y1, or this could be x1, y1, whichever one we like. We'll go ahead and, since they're in order, let's make this the x1, y1, and make this the x2, y2. And like I said, it doesn't matter. You can choose either one. It's just that if this is x1, this has to be y1. You can't say this is x1, y2. That's the only problem. But you can pick either one to be your first one and your second one. So this says the slope equals y2 minus y1. y2 is 3, y1 is 1, x2 is 16 minus 8. 3 minus 1 is 2. 16 minus 8 is 8. So that simplifies to 1/4. So that's our slope. 1/4, right? Using the slope equation. Then you write the point slope form. So with our point slope form, and I'll see what they use. They're using 8-1. You can do it with either one. Oh, sorry, that's not what I wanted to switch to. Let's switch back to this. We know what point slope form is. We just talked about that. That's the y minus y1 equals slope x minus x1, right? That's the point slope equation. Well, we have 2 points. We can use either one. 1/4. So we could say y minus, maybe we want to use 16/3. So the 3 is the y equals 1/4 x minus 16. That's fine. We could have chose the other one if we wanted. This is the exact same line, y minus 1. Same. Because it goes through both those points. The line will go through 8-1 and will go through 16-3. So I can choose either point to write the equation from that. So let's prove that to ourselves now. Let's go back to Desmos and graph all of this. Okay, it's got 2 points it goes to. One of them is the point 8,1. Oh, not 8,1. There we go. And the other point is 16,3. Zoom out a little bit, see both those. There it is. There's our plane coming down, 16,3 and 8,1. And then we wrote two different equations for that. Y minus 3 equals, and then we said the slope was 1/4, and then the x minus 16. Oh, look, there it is using the 16,3 point, and it does go through both of those points. Let's turn that one off and write it with the other equation we had. Y minus 1 equals 1/4 x minus 8. That one also goes through. See, that's the exact same line. We just wrote it using the first point, 8,1, as opposed to the second point, 16,3. So we can do it with either point. So just showing that. And then we can determine the slope-intercept form. Okay, that's a good practice too, like I said, moving from one to another. So let's take the first one up here. Y minus 3 equals 1/4 x minus 16. And say, what if we want slope-intercept? Y equals mx plus b. Right, that's the easiest one to graph because we know where it crosses the y and what the slope is. So if we convert this, the first thing we have to do is get rid of the parentheses. Y minus 3 equals 1/4 x, and then 1/4 times negative 16, negative 4. Now let's move this over. The 3 has to get away because remember, this is y equals, so we don't want anything with the y, so let's move it over. Y equals 1/4 x minus 1. If we'd done it with the other equation, y minus 1 equals 1/4 x minus 8. Again, we get rid of the parentheses. Y minus 1 equals 1/4 x, and then 1/4 times negative 8 is negative 2. Move the 1 over. Y equals 1/4 x. Negative 2 plus 1 is negative 1. Okay, we'll come up with the same equation, which we should because it's the same line. We just wrote it with either point. So if we graph that one, y equals 1/4 x minus 1. Oh, the minus 1 goes after it. There we go. 1/4 x. I got to get that x out of there. There, 1/4 x. Whew. Had my x in the denominator. 1/4 x minus 1. Same line again. That's the same as the green line we had, which is the same as the blue line that we had. So 3 different ways to write that. I mean, these are the same way, just using 2 different points, or the y equals mx plus b. And that's what they got. Y equals 1/4 x minus 1. So it goes through the steps here again if you need it, but we just did that on paper. Restrictions. Oh, see, based on the situation, when graphing equations function, it may be necessary to note the limitations of the domain and the range. You know, for example, if this was actually our airplane that we were talking about, if it landed right here, 4 miles away from the airport, that wouldn't be good, first off, because then you got to walk a long ways to get your luggage. 4 miles away from the airport. But if this was the airplane, we would restrict the domain. First of all, the airplane's not going to crash and go underground. If it crashes, it's going to stop at 0. If it lands, it's going to stop at 0. So the y would have to be y is greater than 0 or equal, right? Greater or equal to 0. That's our restriction on the domain. So it's all this area up here in the gray that it shows. This is not part of the graph. We would have to stop the graph right there, which we could do. We could say squiggly y is greater than or equal to 0. Squiggly. All right. It only wants us to restrict the x. X is greater than or equal to 4. There. See, now it stops the graph at x is greater than or equal to 4. We couldn't have an x smaller than 4 with this equation just because that would put the y below 0. So the x has to be greater than or equal to 4, the y has to be greater than or equal to 0, because in a real life situation, the plane's not going to be underground. So since y cannot be negative, the smallest number can be a 0. And then you solve for x when y is 0, which would be 4. That's what we just talked about. So x has to be 4 or greater, y has to be 0 or greater. Does that mean that the plane lands 4 miles from the airport? Yes. If they don't change their trajectory, the plane's going to land 4 miles away from the airport. That's why he changed this trajectory, that last piece of the graph, and went down 1 mile in the last 8. Airplanes adjust their trajectories during flight due to a number of real-world constraints, wind or turbulence or other airport traffic. So it'd be wise for the pilot to change his trajectory before he lands 4 miles away and makes all the passengers mad that they have to walk 4 miles to the airport. All right. Here's another example on writing the equation of a line with 2 points. So if you want another example, here's another one that they have in our lesson using these 2 points. So I'll let you go through that if you need it. Writing the equation of a line given its graph. Okay, here's the other way around. Now they're just going to give us the graph, and we have to come up with the equation of the line doing that. So let's look at their little video showing that.
To write the equation of this line, you first need to identify some of its points. Look for where the line lies on top of the intersection points on the grid. Now, identify the slope by counting the rise and the run between any 2 points. From one point to another, count down 2 spaces and to the right 1. So the slope of the line is -2 over 1, or just -2. The y-intercept is found where the line crosses the y-axis. In this case, the line crosses the y-axis at -1. So the y-intercept is the point 0, -1. Now you can use the slope and the y-intercept to write the equation of the line in slope-intercept form. Just substitute the values. You can rearrange the slope-intercept form of the equation to get it in standard form. Just collect variable terms on the left and constants on the right.
All right, there we go. Quick little example on if you have the graph and need to write the equation of a line. Again, we learned this in Algebra 1, so this is a good review. Show more on writing the equation of a line with the graph. Here's another example for you if you want to go through another one. There we go. Now it gives you this. Could you write the equation of this graph? Now this has a y-intercept that's really unknown. It's somewhere between 1 and 2. It might be 1.5, but we don't know. So in this case, we'd probably pick 2 points that it definitely goes through. There's several points it goes through. And use that method with the 2 points to write it, because the y-intercept might be 1.5. It might be 1.48. We don't know. So we have to find 2 points that it actually goes through. And we can determine the slope with that. The slope is 1/2 because it goes up 1 and over 2. Remember, rise over run, rise over run. See, it's somewhere between 1 and 2, so we can't use that. We can use the points on the line and the slope. So this is finish the problem on your own, check your work when you're done. So here's, depending on which point you use, here's one where they use this point, here's one where they use this point. But either way, they come up with the standard form, x minus 2y equals -3. All right, so that's another example there. And there's the lesson summary, which means we made it to the end of this lesson on writing the equation. This is a great place to get notes from, or print this as your notes if you have a printer and want to do that. But this talks about the standard form, the slope-intercept form, the point-slope form, which we learned in this lesson. Here it is. Point-slope form is easiest when you're just given 2 points. Talks about that. And then the back to, if you have a graph, writing the equation based on the graph. So that's a summary of everything, which means, wow, we're just on page 3. So there's 2 pages of practice problems for you. If you want to make sure you know how to do this, here's a line that goes through the point 1, 2 and has a slope of -1/3. So how could you write that in standard form? Which, first off, when you see this, pay attention what form they want, because that's where you're going to miss some problems. You're going to have it and you're like, but that was right. Like maybe this is 2x minus 1/3, but this is not standard form. So the first and the fourth answer you can already eliminate. It's got to be either the second or the third. So you need to work that and figure out which one of those it is. And there's 3 problems right there. 3 practice problems to see if you can do that. Page 5. Question 1 of 7. They give you this point and this slope, and then you can check your work after you get it. Then you can click and go to the second problem. Gives you this point and this slope. And then you can go to the third problem. 2 points. Check your work. They'll give you the answer. 2 points. And they want it in slope intercept form. What they want this back here? They wanted this one in standard form. So that's the difference. Then we have, write the equation, this line in slope intercept form, which is the easiest, right? Because we have the intercept and we can figure the slope. Standard form. You can find it in slope intercept form first and then rearrange it to standard form by putting the x and y on the same side of the equal sign. And then the last one, challenge problem. Find the equation of a line in slope intercept form which passes through these 2 points. The challenge part of this problem is to find the equation without using the point slope form to help you. Ooh, challenge problem. So if you want to work on a challenge problem, there you go. And it'll give you the answers. That's a nice big detailed explanation of that. All right. Let's look at the assignment that goes with this one. So if we go to the next thing here, write an equation of a line. I'll make sure you get 3 attempts. It looks like it's just set for once right now, but I'll go back and check that. Write the equation of a line, slope of -1, y-intercept of next. So this is slope intercept. Very nice. This gives you a point and a slope. Point slope form. This gives you 2 points. And it looks like they've got it in slope intercept form. Here's a word problem. Shamika is tossing acorns into a hole. She started with 800 already in the hole. And boy, she's got a lot of time in her hands. She gets 75 acorns per hour in the hole. Shamika is really bored because she's just spending hours throwing acorns in a hole. Write an equation that represents the amount of acorns in the hole where H is the number of hours. So if there starts with 800 already in the hole, I should tell you something, because that's the starting point at 0 hours. At 0 hours, we already have 800 acorns. So that is, spoiler alert, that is your y-intercept. And then we have Brad with a savings account. He gives you the equation for g of x, which is the amount of money in his account. X is the number of weeks. Suppose that the 25 right here changed to 35. What does that mean? Does that mean his initial deposit? And initial deposit means your first deposit. That's when you open the account. So does that mean that increased or decreased? Or is that the amount that he's putting in his bank account increased or decreased? If 25 changes to 35, what does that mean? So that's a good one. All right. That is the 5 problems for equation 1.0 for this lesson 1.05. Let's look at our second lesson, comparing functions. This is important. If we have 2 functions, can we tell the difference? Do we know what's different? So X marks the spot. One of the oldest treasure maps is a copper scroll that was found with the Dead Sea Scrolls. Right? The Dead Sea Scrolls were found about, well, not quite 100 years ago, but found it over in the Middle East. Apparently, most of the Dead Sea Scrolls are a lot of the scripture that's in the Bible. And this is Dead Sea Scrolls were collection of documents written between 150 BC and 70 AD. So a long time ago. And they were able to take all these Dead Sea Scrolls and compare them with the Bible and find out, wow, the Bible is very, 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 very accurate. Because they can compare stuff 2,000 years ago with because people talk about translations and everything and how, well, the Bible's not accurate anymore because all the translations. Well, these Dead Sea Scrolls were originals pretty much. And it still says the same thing. So that was a big discovery. But along that was a copper scroll that had a treasure map. There were directions to 63 secret locations that held riches of gold and silver. Part of the scroll read, in the ruin, which is the valley of Achor, under the steps leading to the east, 40 long cubits, a chest of silver and its vessels with a weight of 17 talents. Today, only assumptions can be made about where this treasure lies, but a talent back then was like a year's wages, for the average person there. So that's a pretty substantial amount of money back then. So math can also be a little bit like reading a treasure map. There can be hidden nuggets of math gold buried within the sentences of a word problem. So from those clues, you should be able to derive your own treasure map, which would be a graph of the function. Morning, Mr. Granderson. All right, so we're going to learn how the key features of functions can be interpreted in terms of the quantities. And given only a verbal description, how can you create a graph? And what comparisons can be made between the two different functions? Let's see here. Finding key features. This is the important part of it. So Zora loves movies and is going to buy some DVDs to build up her collection. She knows the average DVD costs $21 at her local store. How much would 6 DVDs cost, or 10? It may seem routine, but there's also a function hidden in here. So let's see what steps can be taken to find the solution, and how does that 21 come into play? So check your thoughts right there. So it needs to multiply the number of DVDs that she's going to purchase by the amount they cost. So she could create a function like this. F of D, function of DVDs, equals 21D. Right? The 21 is how much each one costs. So if you buy one DVD, that's $21. If you buy 2, then D equals 2, then it's $42. If you buy 6, D equals 6, it's $126, right? So we can write an equation, a function, using the information that we learned up here about her DVDs. So what do D and F of D represent? D is the number of DVDs she's purchasing. F of D is the total cost for that many DVDs. DVD represents the numbers she's going to buy. We know that has to be a positive whole number. So that it is limited in the domain. She's not going to buy -3 DVDs. So it has to be 0 or greater. And the function F of D represents total cost, which would also be 0 or greater. Zora just got a text from her mom. She's got to pick up a gallon of milk. So no matter how many DVDs she purchases, she's still going to buy that gallon of milk, which costs $3.50. So how much is she going to spend when she's out? We can just add that in our function. She's going to spend $21 for every DVD, plus she's going to spend $3.50 because she's got to buy the gallon of milk. That's not optional. She's going to do that. So if she buys 0 DVDs, we put 0 in for D, and she'll just spend $3.50. If she does buy any DVDs, we just substitute that number in. But see, we have this nice function that we can do based on this word problem. All right, one last item to think about for Zora's trip. Is her function increasing or decreasing? Well, the more DVDs she buys, the more she's spending. It's got to be increasing. It's not a decreasing function. It's going to be going, it's a positive slope. It's an increasing function. In this situation, the function is increasing. If you put your arm straight out to your sides like an airplane and tilt your arm, left arm points down. Let's see for you. Is that way for you? Her total will go up. It's an increasing position. All right. Look at all the features that interpreted. So we ended up with this equation. F of D equals 21D plus 350. The slope was 21 because that's how much each DVD costs. The y-intercept's 350 because that's the cost of milk, which she's a required purchase she's going to get. So D and F of D, amount of DVDs and total cost. Is it increasing or decreasing? It's increasing because as she buys more DVDs, the total cost goes up. The slope is positive also. That also tells us it's increasing. If we look at the slope, and the slope is a positive number, 21D, 21 is a positive number, it's an increasing function. Creating graphs from verbal descriptions. So looking for treasure without a map would be pretty ineffective. It'd be hard to do. Sure, the directions are given, but you need to be able to see the landmarks. So the key features that were interpreted from Zora's situation helps you graph. So if you know she wants to purchase some number of DVDs and got to buy the gallon of milk, let's see what the graph would look like. The y-intercept is $3.50 because that's if she buys 0 DVDs. The x-axis is the number of DVDs she buys. The y-axis is the total cost. And that's usually true in a word problem. If there's a total cost involved, it's generally the y. There are some exceptions to that, but as a rule, start thinking the y is the total you're going to spend. So we know that at 1, it goes up 21. So the slope is 21. And so we graph the second point 21 higher than the y-intercept. And then the second point is another 21 plus that. So it's up at 45.5. So that is using that information to make a graph. So it's easy to see how much money she's going to spend. And that's going to go up a lot pretty fast at $21 each. So she's got to spend, they're going to give us more detailed information that we just talked about. The y-intercept is the cost of the milk with no DVDs. Purchase 1 DVD, puts up to $24.50. See what they tell us on the last one there. The line is the slope of 21 is increasing. So that's one of the things we can tell about it. Is it increasing or decreasing? Did you notice that this graph contains only positive x values? Notice that it stopped. It didn't go back here. The graph doesn't exist behind on the other side of the y-axis. That's because we can't have a negative amount of money that she spends. She's not going to be buying negative DVDs. So in this function, based in this situation, our graph has to stop right there. It does not continue into the negative values. It's impossible for her to purchase a negative number of DVDs. So the domain is all the non-negative integers, or x is greater than or equal to 0. That says the same thing. All right, page 4. Let's refine these skills. Give a new scenario. Russell notices there are 12 bananas in his kitchen. He eats half a banana with his breakfast every day. Sketch a graph showing the function of the bananas in the kitchen per day. All right, so let's think about that. We're going to sketch a graph of the number of bananas in the kitchen each day. So we know it starts with 12. We've just got this line at 12. But every day he's going to eat, so X days, he's going to eat how many? Eat half. Well, so a half is each day, but since he's eating them and we're looking at the amount of bananas in the kitchen, this shows the first day we have 12, but 5 days later we have 14 and a half. 4 days later we have 14. That's wrong because he eats it. So we got to remember this would be a negative number because the number of bananas in the kitchen is going down by a half every day. So that would be our slope. Negative 1/2 would be our slope because that's how many bananas are leaving the kitchen every day. So the amount in the kitchen would be downward to where at day 24, there are no bananas left. So that's where our graph needs to stop. First off, we can't have 0 days. So let's say if we graph it, so the graph only goes from 0 to 24, right? If we're building the graph, because we don't have 0 negative days and we don't have any bananas left after day 24. So 0 is less than x and x is less than 24. And we can just combine that. So there's our graph. Check your graph. All right. They didn't go all the way to 24. They're just on the first 12 days. But that's the y-intercept, 0, 12. And it has a slope of negative 1/2 or negative 0.5. You can do it either way. I just did a half. I could do 0.5. What's the domain? The domain is all positive numbers. It's possible for Russell to graph the number of bananas eaten to fraction day, but not a negative number of days. So it says non-negative numbers. I also restricted it here because you can't have negative bananas. They just said it can't go below 0, non-negative numbers. Let's see, comparing functions. When treasure hunting, it's possible to find a treasure map totally intact, but even when the most pristine treasure map's found, it needs to be compared to current maps because landmarks may change. Key features change over time. Like that one they found with the Dead Sea Scrolls 2,000 years ago, a lot of the things shown on that map don't exist anymore. If they show buildings or trees, they may be gone. So you got to compare that with current maps to figure out where it's talking about. So we're going to compare functions. That's the big part of this lesson here. Is look, we have 4 different representations of a function here. We could have the algebraic function, which is just the equation. We could have the graph of a function. We could have a table representing that function, or we could just have the verbal expression, which is Zora buying her DVDs. These all are the exact same function, what they're showing us. These are all the same function. So they have a video they want us to watch, ways to compare function, because this is important. We're going to need to do this in our assignments and our unit test.
Believe it or not, the same function can be represented in a few different ways. Here, we have 4 representations of a function, and they all look pretty different. But you can still gather key information about a function from each form, such as patterns and values, intercepts, slope, and more. No matter what form a function is presented as, you can still figure out some of the same key features. Here's a quick overview of what to look for, depending on the representation. A function written in verbal form may not look like a function at first, but take a closer look. Hint, look for key words and numbers. In this example, the cost to play the app is a function of the number of coins purchased. The initial cost of this app is $5. This is the y-intercept because no coins have been purchased yet. The $2 for every 50 coins is the rate of change. This positive number paired with the word additional tells you the rate of change is positive. The rate of change is also called the slope because there is a linear relationship between the cost to play and the number of coins purchased. A function represented in an algebraic equation, in this case, slope-intercept form, is pretty straightforward. Y represents the total cost, while X is the number of coins purchased, M is your slope, and B is the y-intercept. Apply the same information to a given equation, and you've got yourself some useful information. A numeric table is another way to represent a function. To get the information you need, look at the headers to determine your variables and at the values in the table to reveal any patterns. Using this table, you can determine the y-intercept by finding the value of y when x is 0. You can also calculate the rate of change by looking at patterns in the numbers. Did you notice the values in the y column are increasing as the x values are increasing? That means your function is increasing. And finally, graphs. A function presented as a graph tells you a lot. First, look at the title, that's obvious, but also look at the labels of the axes. Looking for the y-intercept in a graph? Take a look at where the graph crosses the y-axis. You can determine the rate of change using points on the graph. And notice that the graph is going upward from left to right. This tells you the graph is increasing, and because it is a line, this shows that the slope is positive. So there you have it. Now that you know how to find key features in the different function representations, it will be so much easier if you ever have to analyze and compare key features of functions when you see them in different forms.
Very nice. I like that. That's a good little video there. Yeah, in our assignment, we're going to have, and it won't be the same function 4 times. It'll be 4 different functions that you'll need to compare. It'll say, when you compare, you generally compare slopes, and you compare y-intercepts and increasing, decreasing. So you need to be able to look at a function. Now with this, you should be able to get the slope and y-intercept and tell if it's increasing or decreasing, whether it's a positive slope or negative slope. Do that from a graph. Table may be a little harder because determining the slope, you got to figure out the y over the x. You got to use that slope formula. You have 2 points here. Here's a point x and y, x1, y1, x2, y2. So you have x2, y2, and x1, y1. You just got to use that slope formula to figure out what the slope is. And then being able to pull it from a word problem. So it gets a little bit, you got to pay attention to it. So how to compare. The key features, when it says compare the key features, this is where sometimes I see students struggle. So this is great to have in your notes. So when you're comparing key features, what does that mean? What are the key features? The important pieces That's what the key features are the slope, the y-intercept, and whether the function's increasing or decreasing. And that means when going from left to right. So when it says compare the key features from these functions, this is what you're comparing. Slope, y-intercept, is it increasing or decreasing? If you miss part of that, you miss part of the points on that problem. So here's a nice example for us, right? Example 1. We've got 4 functions. We've got h of x, g of x, j of x, and f of x. Here's the 4 categories. We're going to rank these just based on slope. So just look at the slope. Which one of these, I'm going to turn on the chat where I can see that too. Which one of these has the smallest slope? Is it h of x, g of x, j of x, or f of x? I'll give you a minute to look at those. See if I can make those a little bigger on the screen as well, just to make it easier to see. There we go. That's a bit better. Which has the smallest slope? So we have to look at that. Slope's easy on this, mx plus b. Slope shouldn't be too hard on our word problem, because per hour, that tells you, oh, that must be a slope per hour. Maybe a little hard to see the slope here, but it looks like it goes from 0, -5 to 1, +5. So that's the 2 points. So it goes from -5 up to 5. I'm sorry, over there. And then you got to figure out j of x. How much is it going up? Every time x goes up 1, how much is y going up? If it's easier to find the largest slope, you can do that too. But once you find the slopes for all 4, then it's going to be easy to put them in order. So let's start with this way. First, tell me, what is the slope of h of x? Let's start with the equation. What is the slope of h of x? All right, got some folks on that real quick. Yeah, it's 14, right? mx plus b, 14. The y-intercept's -8. Slope is this. What is the slope of the graph, g of x? And it says it goes to the point -5, 0 down here. I mean, 0, -5. And then at 1, it's at +5. So yeah, so that went up 10 and over 1. So if we're doing rise over run, the rise is +10, the run is 1. So it does have a slope of 10. Good job, Arabella. Has anyone found the slope of the table, j of x? Again, you can use that point slope formula. I mean, the slope formula, just the m equals y2 minus y1, x2 minus x1. Arabella's on it. As the x goes up 1, the y went up 8. Goes up another 1, goes up another 8. So this has a slope of 8 because it's 8 over 1. And finally, what's the slope of f of x, of Steve's job? Per hour, he makes $12.25. That's the only number it even gives you. So $12.25. So the smallest would be the 8. So if we drag that to smallest, j of x is. The largest, we'll do the largest. 14 is the largest one. And this was 10 and 12.25. So 10 is smaller. 12.25 is larger. So the correct order is j of x, g of x, f of x, and then h of x. So that would be one of the things you do in our assignments and on our test, is being able to compare 4 functions like this. And we'd also compare their y-intercepts, which for like Steve's job, his y-intercept is 0. If he works 0 hours, he makes 0 money, right? So reset. See, this one have a 0 y-intercept. This one's got to work backwards. But if we graph that 1, 4, 2, 12, it looks like at 0, it's going to be -4, right? Because it's going back 8 every time. So the y-intercept be -4. The y-intercept's -5, and this one's at -8. So they're actually from smallest to largest, -8, -5, -4, and 0. So y-intercepts. And it looks like they're all increasing. plus 14, plus 10, plus 8, 1225. So it's a little easier to compare on increasing, decreasing, because they're all increasing. All right, example 2. Now they want you to do a y-intercept one again. It's the same one. We just looked at that. Let's see. The y-intercept was -8, 0, -4, -5. So our lowest one, lower one. Oh, wait a minute. Where was the highest one? 0, -4, -5. So 0 is our highest one. -5 would be the lower one. -4 would be the higher one. Same function. All right. Here's the lesson summary. So if you're looking for those notes, right there they are. Finding key features of functions, comparing functions, ways to represent functions, algebraically, graphically, table, or verbally like a story. And that's what you'll be comparing. Gives you some more practice on page 6. Interpret the key features of the following situation. Remember what the key features are. Is it increasing, decreasing? What's the slope? What's the y-intercept? I'll let you do that. Check your work right there. Question 2, another word problem. Check your work. So this is good practice. If you struggle with word problems and be able to identify those things, do these questions here on page 6 because it gives you practice and gives you the answers. Here's another one. Let's revisit. So sketch a graph of those, or you can do it on Desmos and then check that. Could you graph those 2 problems up here? This is the same problems. Down here gives you 4 functions based on their slope. Here's a practice problem. Can you put those in the right order? And you'll know if you're right or wrong, right? And lesson summary again. Oh, it gave us a lesson summary twice. Yeah, that's the exact same lesson summary. So they gave you the lesson summary twice, both pages. Let's look at the assignment that goes with this one. All right, comparing functions. Which graph represents Tony's situation here? Which graph represents that? She wants to write 8 entries. Which graph represents that? Here's 3 functions that make it a little easier. Which one has the largest slope? Here's a table. Now, they didn't draw the table, but that's the table. Here's an equation. Here's a word problem. Which has the smallest slope between these 3? Which function has the slowest y-intercept? There's a graph, word problem, and an equation. Oh, that's it. 5 problems. 5 problems. Comparing functions. So it's great if we can write functions and do all that kind of stuff, but if we don't know how to compare them, we're missing out on a lot. We should be able to pull that information out and compare our functions. So if you have any trouble with this or anything else you need to, we'll have class on Thursday. But it's optional. As long as your grade's over 70%, you don't need to be here Thursday, but you're certainly allowed to be here because I'll be here. So you may want to come. Maybe you've taken this and you're like, oh man, I've taken it twice and I'm not done well. I need to go see Mr. Brock because obviously I'm missing something. And so we can talk about it and get you where you can do great on the 3rd one. But hopefully you do those practice problems, nail it, and be able to do this in one shot. But all right, guys. That's all I've got for you. I'm not going to keep you. I'll be here in class if anybody needs to hang around. I want to work on the assignment where I'm here to help you. Any of that, it's all good. But otherwise, I won't make it mandatory to stay. So go have a great Tuesday, guys, and we'll see you next time.